Welcome to fluid mechanics. This is another different model. So if the velocity distribution over a plate is given by u. So now he has not given the velocity, but he has given the velocity distribution profile. So u is
the programmed
2 by 3 y minus y square. This is the velocity profile distribution, in which u is the velocity in meter per second at a distance y meters above the plate, and determine the shear stress at y is equal to 0 and y is equal to 0.15 meters. So you have to find out the shear stress at y is equal to 0 and shear stress at y is equal to 0.15 meter, and take the dynamic viscosity of the fluid, and mu value is given as 8.63 poise. 8.63 poise, right? If you see here, if the velocity distribution over a plate is given by, in which u is the velocity in meter per second and distance y from the meters above the plate. Okay, now I will show you. There is a plate or fixed plate and a mobile plate or whatever. So he wants to find out, he has given the dynamic viscosity of the fluid, whatever the fluid flowing between the two plates, and mu value is given, and he asked you to find out shear stress. What is the shear stress required to maintain this velocity profile? This is the velocity profile he has given, and he asked you to find out the shear stress at a distance y. Y is 0, and means at the bottom of the plate at y is 0 and at y is 0.15 meters. What will be the shear stress? He asked you to find out the shear stress at these 2 points. He has given the dynamic viscosity and he has given the velocity profile. So this is the, for example, this is the velocity profile. So he has given this velocity profile equation. How much? U is 2 by 3 2y by 3 minus y square. So velocity profile, this velocity profile is given, and dynamic viscosity of the fluid is given, and he asks you find out the shear stress here at the bottom and at the top of the plate, right? Okay, how you are going to do it? First we have to write, this is the given data. What you have to do, we have to find out, we have to write the relationship. Tau is equal to mu into du by dy, right? What you have to find out? Tau at y is equal to 0. First you have to find out this one. So du by dy, you know the velocity, right? First you have to find out, see, shear stress you need to find out. This you know, and this you don't know. This also you have to find out. So what is u? 2 by 3 y minus y square. What is du by dy? So du by dy will be equal to d by dy of 2 by 3 y minus y square. So that means d by dy of 2 by 3 will be 2 by 3 y square 2y. Okay, this is du by dy. This is du by dy. You need to know? You need to know du by dy at y is equal to 0. That means you have to substitute 0 at y. So 2 by 3 minus 2y. So 2 by 3 minus 2 into 0, that is 2 by 3. So what is the shear stress? Shear stress at y is equal to 0, that is equal to mu into, that means 8.63 into du by dy at y is equal to 0, that means 2 by 3. So you will get the answer. You will get the dynamic viscosity, you will get the shear stress at y is equal to 0. So next, du by dy at y is equal to 0.15 means 2 by 3 minus 2 into 0.15. That is 2 by 3 minus 0.3, right? So 2 minus 0.9, 1.1 by 3. This is 1.1 by 3. So what is shear stress at y is equal to 0.15? That is 8.63 into 1.1 by 3. You will get in poise. In poise. Oh, sorry. So this is in poise, right? That actually, if you convert into Newton second per meter square. So what we know? We know 10 poise is equal to 1 Newton second per meter square. So 1 poise will be equal to how much? So divided by 10 or you multiply with 0.1. So this will be 8.63 poise. That means how much? So you can write 0.863 Newton second per meter square and 0.863 Newton second per meter square. You will get dynamic viscosity at different points, right? This is 0.863 Newton second per meter square. So this is the way to calculate the dynamic viscosity in the second problem. I hope you understand this. Now we will moving to next problem. So finally you will get the answers. Finally shear stress at bottom of the plate will be 0.5856 Newton per meter square, and at 0.15 distance away you will get 0.3167 Newton per meter square. Now we'll try to solve third problem. Yeah, carefully see this problem. This is one of the important problems. Mostly you will get come across in competitive exams or university exams. So first, calculate the dynamic viscosity of an oil. See, to solve any fluid mechanics problem, first you have to segregate. You have to identify the dependent variables and given variables, dependent variables and independent variables. Then we have to identify unknown and known variables. So and also you need to know the relationship between the known and unknown variables. So that means if you want to solve any fluid mechanics problems, first you need to know the relationship between them. That means formulas. So what is the relationship between the two different variables? Once you know the relationship, then you have to identify what is the data is given, what is the known variables in that particular equation, and then what is the unknown variables. And sometimes you have to know the assumed variables. Some values may not be given, but based on the properties you have to assume that you need to consider. We will discuss in detail, you don't need to worry. First I will try to read the problem. Calculate the dynamic viscosity of an oil. So he has to find out, first identify given data. So first he asks you to find out the dynamic viscosity of an oil. So that you have to find out, which is used for lubrication between a square plate of a size 0.8 by 0.8 meters. So this is the oil he has given, and what he said, this oil is used as a lubrication between the plate, square plate, right? The area of the plate is given. How much? The area of the plate is given 0.8 into 0.8 meter square. 0.8 into 0.8 meter square. And an inclined plane with the angle of inclination 30 degrees. So an inclined plane. So the plate is in inclined plane with the angle of inclination 30 degrees. Right? The weight of the square plate is 300 newtons. So the weight, whatever this plate has, the weight of the square plate is 300 newtons. And it slides down inclined the plane with a uniform velocity of 0.3 meter per second. So the plate is moving down with a velocity of 0.3 meter per second. So thickness of the oil film, so this one, the thickness of the oil film is given as a 1.5 mm. The thickness of the oil film is given as a 1.5 mm. Okay, this is the data given. So what is given? Mu value have to find out. U is given 0.3 meter per second, and area of the plate is given 0.8 into 0.8 meter square, and thickness, that means dy or y, you can say dy or y, thickness is given 1.5 sorry 1.5 mm, 1.5 mm. Okay, this is the given, right? And also inclination is given and weight is given. I am not going to write here, why I will tell you. So first, this is the data is given. You can say, okay, another data I can write. Weight is given 300 newtons and theta angle of inclination of the plane is given 30 degrees. This is the data is given, right? So first, once you identify the given data, first what you have to do, you have to write the relationship between the known and unknown variables. What is the relation between known and unknown variable? So tau is equal to mu into du by dy. Tau is equal to mu into du by dy. What is mu here? Dynamic viscosity. That you have to find out. Du, do you know du? Yeah, you know. You know the velocity. Initial velocity is 0. Du, you know. This you have to find out, right? Dy, you know, right? You know dy. Shear stress, what is the shear stress? Stress is equal to force per unit area. So what is the force? That you don't know. It is not given. But area is given. Area you know, force you need to find out. So to find out this force, what is the other data is given? Weight and theta. Right? Weight and theta. So if you see here, if you resolve this into, this is the inclined plane, vertical and horizontal component. If you resolve this weight into vertical and horizontal component, this will be W cos 60 degrees. W cos 60, because this is 30, and if you say this is 90 and this is 60 degrees. This is 60 degrees, so this one will be W cos 60. So W how much? 300. So force is 300 cos 60 divided by area how much? 0.8 into 0.8. So you will get shear stress. So now you know shear stress, you know du, you know dy, you can calculate dynamic viscosity, right? This is the way to solve the problems. First you have to understand the problem and you have to segregate the known and unknown variables. Once you know the known and unknown variable, then you have to find out the relation between known and unknown variables. Okay. Yeah. Once you convert this into meters, area you can calculate, theta you know, W you know, U you know, dy in mm. So we have to convert it to meters. So you have to multiply with 10 to the power of minus 3. Once it is done, we know W cos theta. I showed you how we got W 300 cos 60 will be 150, cos 60 is 1 by 2, right? So you know the force. You can calculate the shear stress, force per unit area. Then the formula is tau is equal to mu into dou u by dou y, sorry du by dy. So u is the velocity you know, dy you know, and just substitute the variables. Finally you got 1.17 Newton second per meter square. So mu is 1.17 Newton second per meter square. How to convert into poise? You have to multiply with 0.1, right? So that means 0.117 poise. So it will be multiplied with 10. Okay. So I am converting. So yeah, 10 poise is equal to 1 Newton second per meter square. So this is actually reverse. Yeah, if you see 10 poise is equal to 1 Newton second per meter square, that's why you have to multiply with 10, you will get poise. So it will be 11.7 poise. Next, till now we have discussed about dynamic viscosity and we have solved few problems related to dynamic viscosity. Now we are going to deal with kinematic viscosity. Yeah, kinematic viscosity is nothing but it is the ratio of dynamic viscosity by mass density. So kinematic viscosity represented with nu, which is the ratio of dynamic viscosity by mass density. So dynamic viscosity, what is the formula for dynamic viscosity? Newton second per meter square. Mass density kg per meter cube. But if you see, this is in newtons and this is in kg, so we cannot convert. So what we have to do is, we know the weight is equal to mass into acceleration due to gravity. Therefore Newton is equal to kg meter per second square, right? So you can use this expression, right? kg will be equal to Newton second square by meter. Newton second square by meter. So just replace here, you will get Newton second per meter square by Newton second square by meter into meter cube. So Newton will cancel, second will cancel, meter square will be cancelled here. Finally you will get meter square per second. So what is the units of kinematic viscosity? It is meter square per second. So in CGS units you can say mu is centimeter square per second. That means that is equal to Stoke. That is equal to Stoke. So you can say 1 meter square per second, 1 meter square per second will be equal to 10 to the power of minus 4 Stokes. 10 to the power of minus 4 Stokes. Okay. Sorry. Yeah. So which is equal to Stokes, right? So 1 meter square. Okay. So 1 Stoke will be equal to Stoke in centimeter square per second, but meter square dynamic viscosity in MKS units we will represent in meter square per second. So that means 1 Stoke is equal to 10 to the power of minus 4 meter square per second. Right? 1 Stoke is equal to 10 to the power of minus 4 meter square per second. This you have to remember. Because in most of the problems he will give in Stokes, you have to convert into meter square per second. And also in dynamic viscosity you have to remember 10 poise will be equal to 1 Newton second per meter square. This is also you have to remember. These two formulas, relationships you have to remember, because in most of the problem the data is given in poise or Stokes. Okay, this is about dynamic kinematic viscosity. What is kinematic viscosity? It is a ratio of dynamic viscosity by mass density. Now we'll try to solve one problem. Yeah, now try to solve one problem related to kinematic viscosity. Yeah, first I will read the problem. Find the kinematic viscosity of an oil having a density of 981 kg per meter cube. So that means he asked you to find out the kinematic viscosity. So nu you have to find out. Having a density of an oil. So here he used an oil of density. Density of the oil is given. Density of the oil is 981 kg per meter cube. Density of the oil is given. The shear stress exerted by the oil is, so shear stress is given how much? 0.2452 Newton per meter square. Velocity gradient at that point is 0.2 per second. Okay, he has given the velocity gradient. What is the velocity gradient? Du by dy. So du by dy is given as 0.2 per second. 0.2 per second. Okay. Now this is the variables are given. So what you have to find out? Kinematic viscosity. So now what is the relation between the kinematic viscosity and dynamic viscosity? So what is the kinematic viscosity formula? Mu is equal to dynamic viscosity by mass density. You know mass density, you have to find out kinematic viscosity and you have to find out dynamic viscosity. So dynamic viscosity is unknown, right? So you cannot calculate. So to find out the kinematic viscosity, you need to find out the dynamic viscosity. So what is the variables are given for dynamic viscosity? What is the formula for dynamic viscosity? It is tau is equal to mu into du by dy. So tau, is it given? Yeah, shear stress is given and du by dy is also given. So you can calculate the dynamic viscosity. Once you know the dynamic viscosity, you can substitute here. You know the density and you know the dynamic viscosity and you can calculate the kinematic viscosity. Now first we have to find out the dynamic viscosity. So now I am writing the formula. Tau is equal to mu into du by dy. That means mu is how much? Mu you have to find out. So tau is 0.2452 and du by dy is given as 0.2 seconds and mu, right? Mu is equal to 0. So mu is 0.2452 by 0.2 Newton second per meter square. This is the dynamic viscosity. You know the dynamic viscosity, you can substitute in the equation. You can say this is 2 and this is 1. So equation 2 you will get mu is equal to how much? 0.2452 by 0.2 divided by dynamic viscosity, sorry, mass density. How much mass density? 981 kg per meter cube. Now you will get kinematic viscosity. Clear? So if you solve it, finally you will get the kinematic viscosity in terms of meter square per second, that is 1.125 into 10 to the power of -2 meter square per second. If you convert into Stokes, it will be 12.5 Stokes. And we will try to solve another problem related to kinematic viscosity. So you have to find out the viscosity of the fluid having a kinematic viscosity 6 Stokes and specific gravity. See, first what is given in the problem? Viscosity you have to find out. This viscosity means dynamic viscosity. So mu you need to find out. Kinematic viscosity nu is given, that is 6 Stokes. 6 Stokes, that means 6 into 10 to the power of -4. So 1 Stoke will be equal to 10 to the power of -4 meter square per second. This you have to remember. So 1 Stoke is equal to 10 to the power of -4 meter square per second. 6 Stokes will be equal to 6 into 10 to the power of -4 meter square per second. You know kinematic viscosity. Specific gravity is given, right? Specific gravity is given as 1.9. So what is the relation between the dynamic viscosity and kinematic viscosity? This mu is dynamic viscosity by mass density. So you have to find out this dynamic viscosity. Kinematic viscosity you know and density you don't know, right? So without knowing the density you cannot calculate the dynamic viscosity. To calculate the density, what is the formula is given? Nothing, right? He has provided only specific gravity. Now you need to know the relation between the specific gravity and mass density. What is the formula for specific gravity? Specific gravity is nothing but the density of the fluid by density of the standard fluid. Density of the fluid by density of the standard fluid. Now specific gravity you know. Density of the fluid you have to find out. Density of the standard fluid. So what is the density of the standard fluid? So here he has mentioned a liquid, but he has not mentioned what it is. Right? For liquids, I will tell you, for liquids, density of the standard fluid is water. Density of the standard fluid is water. What is the density of the water? Density of the water is 1000 kg per meter cube. So this you have to assume. So density of the water is 1000 kg per meter cube. Now you can calculate. S is 1.9 and density of the fluid you need to find out, and density of the standard fluid is 1000 kg per meter cube. That means density of the fluid is 1900 kg per meter cube. So density of the fluid is 1900 kg per meter cube. So whatever the liquid used in this problem is having a density of 1900 kg per meter cube, right? So now you know the density. You know the kinematic viscosity. Now you can calculate the dynamic viscosity. So mu is equal to mu by rho. So mu is 6 into 10 to the power of minus 4 Stokes meter square per second will be equal to mu in by 1900. So now 1900. So mu will be 6 into 10 to the power of 4 into 1900. So you will get the kinematic viscosity. Okay. So if you calculate, finally you will get 11.4 poise. 11.4 poise. Yeah, this problem you can try at your home. First I will explain the problem. Just try you can consider as a homework or assignment, whatever. Just consider here the velocity distribution of flow or a plate is given. So velocity profile is given. I already solved one problem related to the same concept. So that this velocity profile, what are the velocity profile? This is given. U as 3 by 4 y minus y square. Velocity profile is given. In which the velocity in meter per second at a distance y meters. So this distance y meters, velocity u in meter per second. Okay. Determine the shear stress. Tau you need to find out. Taking at y. So dy value is given as 0.15 meters and dynamic viscosity mu is given as 8.6 poise. So what you have to do is tau is equal to mu into du by dy. So du by dy is given. Du by dy you have to calculate from this equation and you have to substitute. So du by dy at y is equal to 0.15 meters, right? And mu is already given. So you have to convert into meter per second and dynamic viscosity is given. Then you can calculate the shear stress by using this formula. This is this so this you can calculate. It's very easy problem. We already solved one problem, probably same numericals, right? Yeah. And one more problem. Yeah, once you solve you will get this. Yeah, one more problem I will just try at our home, and if you have anything, and you can mail me or if you have any questions. So next problem is the space between the two square flat parallel plates is filled with oil. Okay, there are two square parallel plates, so which is filled with an oil. Okay, each side of the plate is 60 centimeter, so it's a square plate, right? So area will be 0.6 into 0.6. So area you can calculate. The thickness of the oil film. So the thickness of this oil film is given. That means dy is 12.5 mm. And the upper plate which moves at a speed of 2.5 meter per second. So here the velocity is given 2.5 meter per second. Upper plate velocity is given, which is required force of 98.1 Newton to maintain this speed. So F is given 98.1 Newton speed. So you have to find out dynamic viscosity and you have to find out the kinematic viscosity, right? And oil specific gravity is given. So S is given as 0.95. So we already solved similar kind of problems. Just try, and if you have any questions you can ask me. So just you need to find out the dynamic viscosity. So you have to use the formula tau is equal to mu into du by dy. So du you know and dy you know. So tau you can calculate because you know the force and you know the area. You can calculate the shear stress. From that you can calculate the dynamic viscosity. Once you know the dynamic viscosity, specific gravity is given. From that you can calculate the specific specific density of the water or density of the oil used in this lubrication in this problem. So then that you can use in calculation of the kinematic viscosity, which is you can divide it by the dynamic viscosity calculated in the earlier, that with density of the fluid. So these problem you can try at your home, and if you have any questions you can mail us. So thank you for your attention, and next class we will discuss about the other fluid properties. Thank you.